Okay, this is the solutions for Unit 1 review in Math 3. So for the first one, they're asking you to write the equation. So when I look at this graph here, it's a horizontal line, so it's linear, and it crosses the y-axis, and it crosses the y-axis at 2. So that equation would be y equals 2. So again, it crosses the y-axis at 2. For question number 2, again, this is a linear equation, and it crosses the x-axis, and it crosses at -1, -2, -3. So it crosses the x-axis at -3. Question number 3. Again, this is a linear equation. So the equation for that is y minus k equals m times x minus h. And hk is any point, and m is your slope. So I can choose any point that's marked. So I could choose this one right here, and that value would be 0, -1. And then to find the slope, I'm just going to look at the distances. So I'm going to go from one point to the next, and it doesn't matter which direction. So for this one, I'm going up 1 unit, so that's positive, and to the right 2 units, also positive. So up is a positive direction, and right is a positive direction. So then my slope, rise over run, so it would be 1/2. So that equation, using these two pieces of information, there's h, there's k. I'm going to substitute those values into here. So I have y minus k equals m times x minus h. So replace h, replace k, and then simplify. So a double negative. I don't need to have x minus 0. I can just have x. And then I'm going to subtract 1 to the other side. So that equation would be y equals 1/2 x minus 1. Equation 4, I have a parabola with my vertex being 0, 0, and that value would be hk. So the general form of that I have to have a power of 2 there, which is a common thing left off. So here is h and there is k. So replace both of those. Again, don't forget the squared. And I still have to find my stretch. So if I go from the vertex to the marked point, I'm going up 2 and over 1. So I know a would be 2. I don't need to have y minus 0. I can just leave that as y. And I don't need to have x minus 0. I can just leave that as x. Now I can only use this method to find a if I'm given a whole number. So I'm going up 2 and over 1. If I had to go over more than 1, I would actually have to solve for a. But because I'm only going up 2 and over 1, I can then say my stretch is 2. If I had to go up 2 and over 3, I would have to solve for a different. So again, that only works for a whole number with my run equaling 1. So my equation would be y equals 2x squared. Equation 5, or question 5. So I have the same parabola. My vertex is -2, 0. There's h and k. And then given this point here, over 0 down 2. So in this case, if I look at my stretch, I'm having to go down 2 and over 2. So because this is over 2, I have to solve for a. So this is a given point, x and y. So in my equation, I have y minus k equals a x minus h squared. Replace my k value with 0 and my h value with -2. So in order to solve for a, I need to replace x and y, and that's where this extra point is going to come in handy. So replace y with -2. This double negative is a positive. And I just realized I forgot to replace x. And then simplify. -2 minus 0. 0 plus 2 is 2. Squared is 4. So that's the same as just -2 equals 4a. And then divide by 4. And then when I reduce that, I'll get -1 over 2. So I just have to put this back into this equation here. So I know a, and I know my vertex. So again, I don't need to have the y minus 0, so that would just be y. And then a is -1/2. And then x minus -2 is the same as x plus 2. And then squared. Lastly, question number 6 is the same process. My vertex is 1, 2. I have a point up here at 0, 5. So if I look at my stretch, I'm going up 1, 2, 3, and over 1. So because I'm only going over 1, I don't have to solve for a. I can just use my value as 3 over 1. So my equation would be y minus k equals a x minus h squared. And then just solve for y by adding 2 over. And we always just put that at the end. Okay, and then there's lines and parabolas. So now the back side deals with exponentials and absolute values. So for question number 7, this is an absolute value, so that generic equation looks like that. And so my vertex, which is right here, is at 1, 2, 3, and then -2. So there's h and k. And then for my slope, I'm going to count from here to here. So just rise over run. So I'm going up 2, and then I'm going over 3. And the graph is pointed upward, so that means my slope would be positive. So I would have y minus k, which is -2, equals, and then rise over run, absolute value of x minus h, which is 3. This double negative is a positive. And then I'm going to subtract 2. And then that would be my equation. Okay, number 8. So my vertex is here, going over 2 and up 3. There's h and k. And then again, I'm going to count for my slope. So I'm going down 2 and over 1. Just counting the spaces. 1, 2, over 1. It's negative, pointed downward, so that will be negative. So my equation would be y minus k equals m, rise over run, so negative 2 over 1, and then x minus h. And then I'll add 3 over. So negative 2 times the absolute value of x minus 2 plus 3. Okay, question number 9. So this one right here, we should have had a dot bolded here instead of here. So go ahead and fix that problem. So first we're going to draw on our lower bound or asymptote, which is at 1. So my shift or start point is at 0, 1. And then to find my stretch, I go to the second marked dot here, and I'm going up 2 over 1, so it would be at 2. So this is my h, k, and there's my a. So again, everything is from the start or shift point. And the equation for an exponential, so my hk is on my lower bound or asymptote, which was 0, 1, and then my stretch was 2. So y minus k equals a, and then x minus h. So I'm going to add the 1 over. And then I don't need the x minus 0, just the x. So I'm going to get rid of the 0, and then the add 1 towards the end. And then 10, I told you to skip. And 11. So for 11, I have to get y by itself. So I'm going to add the x over. And then divide by 2. So the x divided by 2, I can always put an implied 1 in front of the x, so x and 1x are the same. And then instead of writing it as one whole term, I'm going to write it as a fraction times a variable. So instead of 1x divided by 2, I'm going to do 1 divided by 2, and then times x. So then my start is 0, 0, because there is no number adding to the x and no number adding to the y. And then my slope or stretch is the number multiplying x, so that would be 1/2. So my start is 0, 0. I know this is going to be just a straight line because there's no squared, no absolute value. This is not in the exponent. So then a straight line means I need to have 3 dots in a line. So there's my start point. My slope is 1/2. So I'm going to go up 1 and then over 2, rise over run. Then I have to get another point down here. So I'm just going to do the reverse, down 1, left 2. So then I have 3 points marked on my lattice. And then connect them. And then that gives me my graph. And then it says to do the domain in inequality notation for part of it, interval for the other part. I'm just going to do interval for everything. So for my domain and range, domain is along the x-axis. So I look to see goes forever to the left, so that means forever going to infinity. And then forever to the right, so positive infinity. So this arrow is going, not only is it going upwards, it's also going to the right. So that means to the right to infinity, left to infinity. And we always want to go left to right, so that would be negative infinity, comma, infinity. And then the range is bottom to top. So this is not only going left, it's also going down. So down meaning down forever. And then along the y, it's not only going to the right, but also up. So up and to the right forever, so positive infinity. Then bottom to top, negative infinity to infinity. Okay, and then for this one here, same thing, I have to solve for y. So I need to get the 2x to the other side, and I'll do that by subtracting. I can't actually combine these. Normally I would do 1 minus 2x, but because I'm graphing, I want it in standard form. So negative 2x plus 1. So my start is 0, 1. 0 because nothing is grouped with the x, like in parentheses. And then 1 for the adjustment on y. And then my slope is the number multiplying x, so that would be negative 2 or negative 2 over 1. So start point is 0, 1 over 0 up 1. Again, this is a line for the same reason as 11, no absolute values, no squareds, nothing exponential about it. So my line, I need to go down 2 to the right 1. So I need to get a line, so I need to do the same thing from here but going in the reverse direction. So I will go up 2 and then left 1. And then the domain and the range would be the same for the same reason. Okay, number 13. So for this one, my start point or vertex would be at 1 and then 2. So I need to take this back to 0, so x would be 1. And then normally we would subtract this over, y minus 2. So y would have to be positive 2 to send that back to 0. So 1, 2. And then my stretch is negative 1/2. So I'm going to go to my start, which is 1, 2. So I'm going to go down 1/2 over 1. And then I can do one more point if I go one beyond that, so that's at 3. So that would be when x were 3. That would be 2 squared, which is 4. And then negative 1/2 times 4 is negative 2 plus 2, which is 0. And that would be symmetric, so somewhere there, if I wanted to get a couple of extra there. And then I have my parabola or quadratic. So my domain and range. So domain, this graph, although it looks like it's mostly pointed down, it's also going to the left. So this is not just going down, but also left. So left forever. Same thing here. It looks like it's mostly pointed down, but it's also growing outward, so to the right forever. So negative infinity to infinity. The range is bottom to top always, so I look bottom-wise. So if I look here, although the graph isn't drawn down here, the arrows imply that it's going to drop and go down forever. So negative infinity. And then the height does not go up forever. We have to look to see where on the y it actually stops, and it looks like it stops here on the y. So at 1, 2 is the highest point of my graph, and it's inclusive. Okay, number 14. So my start, or my vertex, is nothing is grouped with the x, so 0, and then my y would be negative 3. Normally I would add 3 over, and then y would have to be negative 3 to send it back to 0. So it would be negative 3. My stretch is the number multiplying x squared, which is 2, or 2 over 1. So graph my start, and then my stretch, up 2 over 1, both directions. And if I wanted to, I can plug in like x equals 2 to find one more point. So the domain is also negative infinity to infinity like the other one was. And then the range, bottom to top. So there's no graph down here, and I can't even imagine it because this is the bottom or the lowest it goes. And that's at 1, 2, 3, so at negative 3 inclusive. And then it's pointed upwards forever, so then it's going to positive infinity. Okay, so that's the graphing there. And backside. Okay, so this one's kind of a weird one because they put the 2 in a weird spot. So usually it would be to the back side, so I'm just going to rearrange that. So it would stay adding because 2 is positive. So my start would be negative 4 and then positive 2. So opposite in here, negative 4. Normally we would subtract 2 over, y would have to be positive 2 to 0 it, so it would be positive 2. Then my stretch or my slope would be the number multiplying the absolute value, which is negative 1 or negative 1 over 1. So graph my start, left 4, up 2. Then my stretch is negative 1 over 1, and I have to go both directions. It's an absolute value. So my lines need to be, or my edges need to be lines, straight lines, not curves. So domain is same as the parabola, is negative infinity to infinity, because it goes both left and right forever. And my range is bottom to top. So bottom, this goes down forever, so we can imagine it extends forever down. And then it doesn't extend forever up, so I have to figure out how high it actually goes. Looks like right around here. So 1, 2. So it goes up to 2. Okay, 16. So my, see my start here. So what's inside grouped with x is nothing, so that'd be 0. And what adjusts my y value is what follows, which is 1. Subtracted over, y would have to be 1 to 0, so 0, 1. And then my stretch or my slope is the number multiplying my absolute value, which is 2 or 2 over 1. So I do my start first, and then my stretch. So I'm going to go up 2 over 1, and the other way. And it's an absolute value graph, so straight lines, V shape. Domain is still negative infinity to infinity. Hope we're seeing a theme here. And then range, bottom to top. So this graph does not go down forever. So it looks like the lowest it goes to is right here. So that would be at 1, and then forever up. Okay. All right, and then number 17. So my start is 1 is up here with the x, so 1, and then nothing adjusting the y because there's no number here, so that would be 0. And then my stretch would be 2. So my start is 1, 0, so I go over 1 up 0. And there's my lower bound or asymptote. So the graph cannot go below that. And then my stretch is 2, so I'm going to go up 2 over 1. And then if x were 1, I would get 1 minus 1, which is 0, 2 to the 0, which is 1. And then just graph it. So domain, forever left, forever up and to the right. My range. So it can't go below this value, so it can't go below 0, and it can't equal 0 because that's part of my asymptote, and then it goes up forever. Okay, last one for this video, number 18. So my start, so I look up here, so is at positive 2 from the x minus 2. And then my adjustment on my y value is 1. My stretch is 2, looking at my base. So I'm going to graph my start first. I'm going to go over 2, up 1, and that gives me my lower bound or asymptote. And then my stretch is 2, so from my start, up 2 over 1. And then if I were to put 2 in here, 2 minus 2 is 0. So 2 to the 0 is 1, plus 1 is 2. And graph. And my domain is negative infinity to infinity, just like it's been for all of them. No surprises there, hopefully. Range, bottom to top. So the lower bound or asymptote is my lowest value that it can approach, which was at 1, but not equal it, and then up forever, so infinity. Okay, so that just covers the first half, and then the second video will cover the second half.